In this video, we're going to prove that in the integers, 0 times anything is 0. So we know that in the integers, there's only one additive identity, and we call it 0. Of course, we also know that there's only one multiplicative identity in z, and we call that 1. We had axioms which stated that there is an additive identity in z, and there is a multiplicative identity in z. And then we proved that they're unique, that the additive identity is unique in z and the multiplicative identity is unique in z. We have additional, besides the existence axioms for those identities, we also have other axioms which govern the behavior of the additive identity and multiplicative identity. A couple of those axioms are here. They state, first, there are no zero divisors in the integers. If n and m are integers and n times n is equal to 0, then n is equal to 0 or m is equal to 0, or possibly both. We had another axiom which stated that the additive identity is not equal to the multiplicative identity. That is, 0 is not equal to 1. Now, another thing we think we know about 0 is that if you multiply 0 by any number, you get 0. Okay, but that's not one of our axioms. So it must be something that we need to prove in order to fit with the spirit of this course and only accept things that we've either agreed to accept as true, as axioms, or things that we've proved. So here we're going to prove that this is true, that 0 times any number is 0. So here's our theorem. If n is an integer, then n times 0 equals 0 times n equals 0. And of course we know as an axiom that multiplication is commutative, so if we can just prove one of those, if we can just prove n times 0 is equal to 0 or 0 times n is equal to 0, then we'll get the other one for free. So here's our proof. Let n be an integer. Again, we need to show that n times 0 is equal to 0 times n, which is equal to 0. And let's have a look at n plus n times 0. The reason we're going to look at that is that if n times 0 really is equal to 0, then n plus n times 0 had better be n, right? Let's see if we can establish that n plus n times 0 is equal to n. Well, we know that n plus n times 0 is equal to n times 1 plus n times 0, just by definition of the multiplicative identity. Then we can use the distributive property to pull out the n, so this is equal to n times the quantity 1 plus 0. And of course 1 plus 0 is 1, since 0 is the additive identity, and n times 1 of course is n. Okay, so we've established then that n times 0 behaves like 0, at least in this equation. In other words, we know that n plus n times 0 is equal to 0. Okay, well now let's add negative n to both sides. So we have additive inverses in the integers, and we know that they're unique to their element. So we have an element negative n in the integers, and we add that to both sides. We'll get on the left-hand side negative n plus n times 0 is equal to negative n plus n. Of course, negative n plus n is 0, and we'll add that to n plus n times 0. We get 0, again on the right-hand side, when we add the additive inverse to n. And of course, that reduces to n times 0 is equal to 0. And so, since multiplication is commutative, we've just proven that n times 0 is equal to 0 times n is equal to 0. That is, 0 times anything is equal to 0. And that's it for this video. Thanks for listening.